Now come to the question number 2. Question number 2. Differentiate e power sin inverse x with respect to x. Okay, my dear children, understood the question, my dear children? Right. To differentiate the given function, here also there are two methods. Okay, my dear children, I will explain both methods. You can follow any method. In examination, you can follow any one of these two methods. Okay, my dear children? Right. Method 1. First method. Let y is equal to e power sin inverse x. You know, first step is we assume that given function is y. So, y is equal to e power sin inverse x. So, in this method, immediately after this step, we start differentiation part. Okay, my dear children, immediately we take the differentiation on both sides. Then what is the differential operator here? If you take differentiating with respect to x, d by dx. So I wrote d by dx on both sides. D by dx on both sides. So d by dx of y is equal to d by dx of e power x. D by dx of e power sin inverse x. Understood this step, my dear children? Right. This implies in LHS, what is there? D by dx of y. Then what is the value of d by dx of y? Dy by dx only. Understood this LHS part, my dear children? Right. Is equal to, come to RHS part. If you observe the function, it is in the form of d by dx of e power x. Assume sin inverse x as x in your mind. Means here we are using chain rule. Understood, my dear children? Differentiation of composite function. So assume sin inverse x as x in your mind. So d by dx of e power x. What is the formula for d by dx of e power x? E power x only. So e power x. X means we assumed here sin inverse x into d by dx of sin inverse x. Whatever the function is assumed as x in our mind, we have to take its differentiation. Understood this part, my dear children? Right. Because d by dx of y is equal to dy by dx and d by dx of e power x is equal to e power x. We used these two results in this step. Understood, my dear children? Right. This implies dy by dx is equal to e power sin inverse x into, this is a standard differentiation, d by dx of sin inverse x. We have learnt differentiation of inverse trigonometric functions. What is the formula? D by dx of sin inverse x, 1 by root of 1 minus x square. Understood this part, my dear children? Right. Because d by dx of sin inverse x is equal to 1 by root of 1 minus x square. Understood this step, my dear children? Right. This implies we write LHS part as it is, dy by dx is equal to, we are simplifying RHS part, e power sin inverse x into 1 by root of 1 minus x square. What will you get here? E power sin inverse x into 1. In the numerator, you get e power sin inverse x divided by, in the denominator, you get root of 1 minus x square. Okay, my dear children, this is the value of dy by dx. Understood, my dear children? Right. We discuss second method also. Okay, my dear children? Right. Now come to the second method. Method 2. In this method, we use the latest knowledge. What is the latest knowledge? We have learnt logarithmic properties in this exercise 5.4. So we use logarithmic properties before starting the differentiation part. Okay, my dear children? Right. So this method is called logarithmic differentiation because before starting the differentiating the given function with respect to x, we are using the logarithmic properties at most level. As far as possible, we are using the logarithmic properties. After applying the logarithmic properties at the utmost level, then we start differentiation part. Up to that, we don't start differentiating part. Okay, my dear children, remember this point in the logarithmic differentiation. Right. So let y is equal to e power sine inverse x. We assume that given function is y. So y is equal to e power sine inverse x. So by taking log on both sides, what will you get here? Log y is equal to log of e power sine inverse x. Okay, my dear children, understood this step? Right. This implies log y is equal to, in RHS, if you observe this function, it is in the form of log a power n. It is in the form of log a power n. What is the formula? Logarithm property, log a power n is equal to n log a. So here a means e and n means sine inverse x. We use that logarithmic property here. So sine inverse x into log e, because log a power n is equal to n log a. We used this logarithmic properties in this step. Understood this step, my dear children? Right. This implies log y is equal to sine inverse x into log e value is 1. In the previous question also we have taken log e value is 1 because log e is equal to 1. Understood this step, my dear children? Right. This implies log y is equal to sine inverse x. Okay, my dear children? Understood this step, my dear children? So ultimately we use the logarithmic properties. As far as possible, we use the logarithmic properties. Hereafter we can't use the logarithmic properties. Then we start differentiating part. Understood, my dear children? Right. So differentiating with respect to x. Okay, my dear children? Right. So here we are taking the differentiation on both sides with respect to x. Then what is the differential operator? D by dx. So I am writing d by dx on both sides. So d by dx of log y is equal to d by dx of sine inverse x. Understood this step, my dear children? Right. This implies in LHS, if you observe, it is in the form of d by dx of log x. Assume this y as x in your mind. We are using here chain rule. So d by dx of log x, what is the formula? 1 by x. So 1 by x means here y only, not x. Okay, my dear children, don't confuse here. Into d by dx of y, because we assumed here x, here y as x. So d by dx of y is equal to, this is the direct formula, d by dx of sine inverse x. In the inverse trigonometric functions, differentiation of inverse trigonometric functions, what is the formula? D by dx of sine inverse x, 1 by root of 1 minus x square. Here we used the chain rule, composite function differentiation. Okay, my dear children? Right. So because d by dx of log x is equal to 1 by x and d by dx of sine inverse x is equal to 1 by root of 1 minus x square. Understood this step, my dear children? Right. This implies 1 by y into d by dx of y. What is meant by d by dx of y? dy by dx only. So I am not writing that step here. Direct I am writing dy by dx is equal to 1 by root of 1 minus x square. Understood this step, my dear children? Right. But finally we have to find the value of dy by dx. So we have to send this 1 by y to RHS. Then it becomes y by 1 into. Okay, my dear children? So dy by dx is equal to y into 1 by root of 1 minus x square. Understood this step, my dear children? Right. This implies dy by dx is equal to, what will you get? Y into 1 in the numerator? Y only. So y by In the denominator, root of 1 minus x square. Understood this step, my dear children? Right. That is equal to, what is y value? E power sin inverse x. At the beginning of this question, we assumed y is equal to e power sin inverse x. So e power sin inverse x by root of 1 minus x square, because y is equal to e power sin inverse x. If you compare the answers in the first method and in the second method, we get the same answer. You can follow any methods in the examination. No need to write both methods in the examination. Remember this point, my dear children. Okay, my dear children, understood? Right.